Hello, today's lesson will be lesson 2.1b, using the greatest common factor in real life. So let's get started. I'll share my screen with you and I'll hit present. Pull down my tools in case I want to write on the screen for you. So today we are going to be talking about the greatest common factor again. This time we're going to be using it in word problems. So your standard is I can find the greatest common factor to answer word problems. I'll move myself over here. And we're working in the same standard as the previous lesson, 6NS4. Find the greatest common factor of two whole numbers less than or equal to 100, and that's what we're working on. The rest of it, the least common multiple, we'll be talking about in a future lesson coming up. And using the distributive property will be our next lesson. So I'm going to minimize myself and we'll get started. Put myself up here, and here we go. So this is a little blurry, but it's just a little meme that says, this is how we chill. Find the greatest common factor of 90 and 175. You are actually going to get the opportunity to do that shortly. Okay, a little review. So what is a common factor? Do you remember from last lesson what a common factor was? It's when two different numbers share the same number, a common number or a factor that exactly divides both of the numbers without a remainder. That number that evenly divides into both numbers is a common factor. So for example, if I said 10 and 5, a common factor of 10 and 5 would be 5. Because 5 will divide into 10 evenly, and 5 will divide into itself evenly. That is what a factor is, a common factor. Hopefully that's review for you. Here's an example. The common factors of both 18 and 30 are 1, 2, 3, and 6. That means that 1, 2, 3, and 6 will divide into both 18 and 30 without leaving a remainder. You can try that if you'd like and pause the video to see that you can divide 18 by 1, 2, 3, and 6 and get no remainder. And you can divide 30 by 1, 2, 3, and 6 and get no remainder. Okay, what is the greatest common factor, better known as the GCF? That is the greatest common factor, the largest number of the common factors of two numbers is the greatest factor shared by those numbers. So the greatest common factor of 18 and 30 is 6. That means that 6 is the biggest number that will divide into both 18 and 30 without leaving a remainder. If you went ahead and tried that on the previous slide, you should see that 6 is the biggest common factor. Okay, moving on. Now it's your turn to do a couple of review problems. I will see you back in a moment. Okay, hopefully you did well on those review problems. If not, you're going to get lots more review today in a different kind of context. So first question, we're going to use the GCF, finding the greatest common factor, for word problems. So here's our first word problem. A florist makes bouquets from 18 roses and 30 tulips. All the bouquets will include both roses and tulips. If all of the bouquets have the same ratio of roses to tulips, that means they're going to have the same number of roses and the same number of tulips in each bouquet. What is the greatest number of identical bouquets that can be made? So for example, if this is my rose right here, and let's say my tulip is yellow, and let's say this is my tulip, Going to be able to draw really good here, but how many tulips and how many roses will be in each bouquet? Will it be one each? Or will it be two each? Or will you maybe have something like 2 tulips in each one? It's supposed to be my tulips. And maybe 3 roses in each one. What is the ratio of numbers? What's going to happen here? How many bouquets can we make with the same number of maybe 3 roses and 2 tulips for each bouquet? So we have to figure that out. And we can use the greatest common factor to figure that out. So let's see how we do it. So step 1, list all the factors of each number. So in our problem, the numbers we have are 18 and 30. So I always, when I start with a word problem, I underline the numbers, I draw a picture if it can help me, and then I look at the last sentence, which is always the question. And then when I'm done, I go back and look at the question to make sure I answered it right. What is the greatest number of identical bouquets that can be made? Okay, so let's list all of the factors of 18 and all of the factors of 30. So pause the video and see if you can list all of the factors of 18 and then all of the factors of 30, and then come back and press play. Okay, did you do it? Let's see if you got what I got. So 18, the factors are 1, 2, 3, 6, 9, and 18. How did I get that? Well, 1 times 18, 2 times 9, and 3 times 6. All of the factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. How did I get that? 1 times 30 is 30, 2 times 15 is 30, 3 times 10 is 30, and 5 times 6 is 30. Step 2, circle all the factors that are common to both numbers, that are the same in both numbers. So we know that 1 is the same. What else? We know they both have 2s. They both have 3s. They both have 6s. Do they have anything else? No, that's it, right? So the common factors of 18 and 30 are 1, 2, 3, and 6. There's our question again. So the common factors of 18 and 30 are 1, 2, 3, and 6. Now our step is to, what do the common factors represent in this word problem? What do they represent? What does 1 represent? What does 2 represent? What about 3 or 6? What does it mean in the context of this question? Well, the possible number of bouquets that can be made with 18 roses and 30 tulips with the same ratio of roses to tulips to make identical bouquets. Yes. So 1, 2, 3, and 6 are the possible number of bouquets. So you could have 1 bouquet with 18 roses and 30 tulips in that 1 bouquet. Or you could have 2 bouquets with 9 roses in each bouquet and 15 tulips in each bouquet. You could have 3 bouquets with 6 roses and 10 tulips. Or you could have 6 bouquets with 3 roses and 5 tulips. So those are all possible combinations using all of the roses and all of the tulips with none left over. Here's the same question. So step 3 in our answer, finding our answer, is find the greatest number from our common factor list. Remember what our list was? 1, 2, 3, and 6 were the common factors of 18 and 30. We could have had 1 bouquet, 2 bouquets, 3 bouquets, or 6 bouquets. What's the greatest number of identical bouquets that can be made? There, going back to my question now. What is the greatest number of identical bouquets that can be made? Exactly, 6, right? 6 is the biggest common factor, the greatest common factor. There's 6. The greatest number of identical bouquets that can be made is 6 bouquets. 1, 2, 3, 4, 5, 6. Okay, let's try some more. So, oh, we're on the same problem. Suppose the florist, no, this is different. Suppose the florist had 18 roses and 36 tulips. Okay, we changed the numbers. So now this time they have 18 roses and 36 tulips. Now what is the greatest number of identical bouquets that can be made? Okay, it's different now, right? What's our first step? List all the factors of each number. Pause the video. See if you can list all the factors of 18 and all the factors of 36, and then come back and let's check. Okay, how did you do? Did you get these factors for 18? 1, 2, 3, 6, 9, and 18. 1 times 18 is 18, 2 times 9 is 18, and 3 times 6 is 18. How about 36? There's a lot more, isn't there? Well, there's a couple more. 1, 2, 3, 4, 9, 12, 18, and 36. 1 times 36, 2 times 18, 3 times 12, or 4 times 9. Step 2, circle all the factors that are common to both numbers. So we're going to circle the 1s. We're going to circle the 2s. We're going to circle the 3s. We're going to circle the 9s. And we are going to circle the 18s. Correct. Okay, clear my screen here. Same word problem. And now the step 3 is to find the greatest number from our common factor list. Remember what our common factors were from the previous slide? 1, 2, 3, 9, and 18. Which one is the greatest? I hope you all said 18. There it is. So what does that mean? The greatest number of identical bouquets that can be made is 18 bouquets. A lot more than when we had the previous numbers, right? Now we can make 18 bouquets, right? Okay, let's go on. New problem. A baker has 24 sesame bagels and 36, that should say plain, 36 plain, put an N in there. It's gonna bug me. N in there, squeeze it in there. 36 plain bagels to put into boxes. Each box must have the same number of each type of bagel. What is the greatest number of boxes that the baker can make using all of the bagels? So I'm going to underline my numbers, 24, 36, and I'm going to underline my question, always the last sentence in the word problem. What is the greatest, and I have a hint there, what I'm going to have to do, what is the greatest number of boxes the baker can make using all of the bagels? It's just like our roses and tulips problem. We have to find the greatest common factor of 24 and 36. So step 1, list all the factors of each number. Again, pause the video, list all the factors of 24 and all the factors of 36, and then check and see if you got what I got. Did you get 1, 2, 3, 4, 6, 8, 12, and 24 for the first number? And then for 36, did you get 1, 2, 3, 4, 9, 12, 18, and 36? Sometimes it's hard to catch them all, isn't it? Especially like the 18 and the 3, like 3 times 18 is 36, you may not, 2 times 18 is 36, you may not know that, or 3 times 12, that one you should know. But 2 times 18 you may not have known. So you could always divide 36 by 2 and see that you get 18. Now step 2 is what? Exactly, circle all the common factors that are in both numbers. 1s, 2s, 3s, there's 4s in both, and there's 12s in both. And by the way, if you prefer using the prime factorization method, go back and watch the previous video if you need a refresher on how to use the prime factorization method. Okay, let's clear my screen. And there's our problem again. We want to figure out how many boxes the baker can make. So step 3 is to find the greatest number from our common factor list. There was our list, 1, 2, 3, 4, and 12. Which one's the biggest? Which one's the greatest? Exactly, it's 12. Right, so they can make 12 boxes. The greatest number of boxes the baker can make, shouldn't say bouquets, is 12 boxes. B-O-X-E-S. He can make 12 boxes. And there are 12 boxes. Okay, let's go on. Okay, same question, right? How many sesame bagels and how many plain bagels will be in each box? We haven't asked this question yet. We figured out how many boxes there are, right? Wasn't there 12? So we have 24 sesame bagels. Our problem told us that. So we're going to divide that by the 12 boxes, which was our GCF from the previous slide. It's supposed to be a G there, GCF. And if we divide 24 by 12, we get 2 sesame bagels for each box. See if you can pause and figure out how many plain bagels will be in each box. How many plain bagels? Okay, should come back now. 36 plain bagels divided by 12 boxes would be 3 plain bagels in each box. Very good. Okay, let's try a few more. Get the hang of this. The 6th grade class is competing in field day. There are 32 girls. I think I'll underline that right away. There are 32 girls and there are 40 boys. I guess I'll underline boys and girls too so I know which is which. Each team must have the same number of girls and the same number of boys. Doesn't mean they have to have this, like they don't have to have 3 girls and 3 boys. They just have to have the same number of girls on each team, whatever that number is, and the same number of boys on each team, whichever that number is, okay? What is the greatest, question, right, number of teams that can be formed? Same as the last 2 or 3 questions. What is the greatest number of teams that can be formed? What's the first step? Yes, list all the factors of each number. So you can pause the video, list the factors of 32, and list the factors of 40, and then come back and check. Here's 32 factors, 1, 2, 4, 6, 8, 16, and 32. Did you get 2 times 16 in there? Good. 6 times 8, let's see, 4 times, 2 times, 4 times 8 is 30. What's that 6 doing in there? 6 should not be in there. I don't think 6 is a factor of 32. Let's take that one out of there. Okay. And then for 40, you should have 1, 2, 4, 5, 8, 10, 20, and 40. Did you get all of those? Okay, good. Step 2 then is to circle all the factors that are common to both numbers. 1s, 2s, 4s, you got this, 8, and that's it, right? Exactly. Okay, clear my screen. Next step. Find the greatest common factor. Greatest numbers, the greatest common factor. We have common factors of 1, 2, 4, and 8. We circled on the previous slide. Which one's the greatest? Exactly, 8 is the greatest. So that means the greatest number of teams that can be formed is 8 teams. 8 teams can be formed with 32 girls and 40 boys. Now we want to ask another question. How many boys and how many girls will be on each team? We decided 8 teams could be formed, right? So if you have 32 girls and you can have 8 teams, how are you going to divide those girls up on those 8 teams? Exactly, you're going to do 32 girls divided by 8 teams equals 4 girls on each team. See if you can do the boys. How many boys will be on each team? Pause the video. Okay, did you come up with 40 divided by 8 equals 5 boys on each team? Excellent job. Great work. Okay, here's another problem. Lee is sewing vests using 16 green and 24 blue buttons. All the vests are identical and all have both green and blue buttons. What is the greatest number of vests Lee can make? He's got 16 green buttons and 24 blue buttons. All the vests are identical. That means they're going to be exactly the same number of green on each vest and the same number of blue on each vest. What is the greatest number of vests Lee can make? Okay, what do we do? Step 1, yes, list the common factors of 16, or list all the factors of 16 and 24. Go ahead and pause the video and do that, and then come back and check. Did you get 1, 2, 4, 8, and 16 for 16? And what did you get for 24? 1, 2, 3, 4, 6, 8, 12, and 24. What's the second step? Exactly, circle all the factors that are common to both numbers. 1s, 2s, 4s, any others? Yes, 8s. So our common factors are 1, 2, 4, and 8. Let's go to the next page and write those again. Now we're going to find the greatest common factor. We said 1, 2, 4, and 8. The greatest is, yes, 8. So what does that mean? That means that the greatest number of vests that can be made are 8. 8 vests. Okay, same question, same word problem. How many green buttons will be on each vest? And how many blue buttons will, that should say be, on each vest? So what do? Right, we divide 16 by the number of vests that can be made, and that was 8, right? So we divide 16 green buttons by 8 vests, and we get 2 green buttons on each vest. What about the blue buttons? 24, oh, should say blue, 24 blue buttons divided by 8 vests is equal to 3 blue buttons. Got too many typos today. 3 blue, I should actually make it the color blue, shouldn't I? So 24 blue buttons divided by 8 vests, the greatest common factor, should equal 3 blue buttons on each vest. Okay, let's move on here. Oops. I'm going to have a dot. Okay, there we go. Now it's your turn to give a word problem or two a try, and I will see you back in a moment. Okay, welcome back. We are now on our focus on higher order thinking. So I'm going to show you another method for finding the greatest common factor. On the last lesson, I showed you the prime factorization method and the list the factors method. On this video, I am just showing you the list the factors method with word problems. You are certainly welcome to do the prime factorization method if you like that better. Or here's a new method you can try. This is called Euclid's algorithm. So this one's a little more complicated, but this is for all you math crazy people that really like math like me, who might want to try this method as well and see that it works. So here are the steps in Euclid's algorithm method. 1, you're going to divide the lesser number into the greater number. So if we had, let's say we had 4 and 8, you're going to divide 4 into 8. 8 divided by 4 is 2. If the remainder is 0, the lesser number is the greatest common factor. So 4 would be the greatest common factor. However, if the remainder is not 0, you're going to keep dividing the remainder into the previous divisor until the remainder is 0. The last divisor is the GCF. Let's see how this works with numbers, because that can be confusing with words. So find the GCF of 128 and 176 using Euclid's algorithm. So step 1, well, here's all the steps. 176, we're going to divide the lesser number into the greater number. So what we did is we took 176 and we divided it by 128. That's the first step. If we do that, it'll only go in there once, and then we subtract 176 minus 128, and what do we get? We get 48 as our remainder. Okay, that's step one. That's what this step is. Then our next step is we take the divisor, this one here, and we divide it by the remainder, which we have from there, right there. Okay, I'm just going to actually undo that because it's blocking things. So now we take 128 on the inside and we divide it by the remainder of 48. The answer is listed there for you. You'll get 2. 2 times 48 is 16, carry the 1, 96. And then you subtract 128 minus 96, and you'll get 32 as your remainder. You're going to do the same thing again. As long as you get a remainder, up here number 3 says if the remainder is not 0, keep dividing. So now 48, this was our divisor this time, that's going to go over here, and we're going to divide it by our remainder of 32. Okay? So let me erase so I have a little bit more room here. So now let's do that. So we have 48 on the inside, and we are dividing it by 32 on the outside. So 32 goes into 48 one time, and then I subtract, and I get 16, right? So 1 remainder 16 here. Now I'm going to do this again, and now I'm going to take my divisor of 32 and divide it by my remainder of 16. So let's do that. And I will erase this one here. Room for that one. And that's our last step. So we're going to divide 32 on the inside this time. So every time the divisor that was on the outside, the next time around it goes on the inside. Okay? We're going to divide it by the remainder that we had from the previous problem, 16. 16 goes into 32 exactly twice. 2 times 16 will give me 32. I subtract, and now my remainder is 0. So the last divisor is your GCF. So divisor is the outside number here. So my last divisor then is 16. So 16 is my GCF. Okay, so that's just another method you could use if you would like to try that. That would be great. I could give you some other numbers you could try that on. You could try them on any of the previous problems in the video and see if you get the same GCF as we got in the video using this Euclid's algorithm method. Clear all my drawings. So I'll come back on for you guys. There we are. And I believe we are at the end of our lesson. And yes, so now remember I told you that I'm putting the homework on Google Classroom because I sometimes change my mind, and if I'm on the video, I can't change my mind, right? It's recorded, and that's that. So I hope that you have a great day, and I will see you in the next lesson. Bye.